All right, so alcohols also have unique acid-base properties, and that's because they can act as acids or bases. Right, so they can be either be an acid or a base in most scenarios. In general, we think of them as weak acids. Although remember, acidity, basicity, it's kind of like height, tall or short. It's all relative to something else. So just to give you some pKa values, an alkyl hydrogen, so a hydrogen attached to an sp3 hydrogen, has a pKa about 45 to 50. And amine has a pKa about 35 to 40. And remember, the lower the pKa, the more acidic the component. And then alcohols have pKa's from approximately 15 to 18, right? So you can see there's kind of a big jump in acidity, and alcohols are indeed considerably more acidic than amines. Not as acidic, of course, as acid halides, which can have pKa's from -3 to about 10. Of course, you want to know the mechanisms of alcohols acting as acids or bases. So, for example, if you have an alcohol and you react it with a base, a common one will be sodium hydride. Right, in this case, it's going to act as an acid. So the hydride is going to come in, pick up this H, this OH bond is then going to become a lone pair on the oxygen. So again, here it's acting as an acid, it's donating that H plus, and then we get a negative charge on our compound. And then, of course, the counter ion, the sodium, that one's just hanging out there. And then the cool thing about using sodium hydride as a base is that you produce hydrogen gas, which then just leaves your reaction, so you don't have to worry about dealing with it. This negatively charged oxygen that came from the alcohol is called an alkoxide. And generally, they get the last ending as "ide." So, for example, this would be sodium ethoxide. It's a pretty good nucleophile, so you can use it to do substitution reactions. It's also a pretty good base, so you can use it to do elimination reactions. As we said, the alcohols can also act as bases. So if you combine them with some stronger acid, so for example, if we have isopropanol and we combine that with hydrochloric acid, in this case, the alcohol will act as the base. It'll pick up this H plus. This HCl bond will become a lone pair on Cl. Oxygen then gets positively charged. And so the cool thing about this is that now we've created a good leaving group. So then we have essentially made this carbon right here more electrophilic, and so we could do substitution reactions with that. Of course, there are better ways to make it a good leaving group without the use of strong acids, as you've seen in the previous semester and as we'll review in these upcoming parts.